Welcome back to our investigation of trigonometry. Last lesson we talked about the law of sines. Now we are talking about the law of cosines. When we were using the law of sines, we could solve triangles when we had angle, side, angle, angle, or side, side, angle. So if we had two angles and a side, or two sides and one angle that was opposite, we used the law of sines. We had two other cases where we want to use the law of cosines. This is when three sides are known, or two sides and the angle between them are known. So here are the cases we will use the law of cosines. Recall the law of sines said that the ratio of the length of a side of the triangle to the sine of the angle opposite is the same for all three angle combinations. The law of cosine addresses these cases where the law of sines does not apply. So let's first imagine a triangle on the coordinate plane with its vertex at 0, 0. We have the triangle is labeled ABC. Point A is at the origin, has x coordinate 0, y coordinate 0. Point B is on the x-axis, and that distance between A and B is C because the coordinate is C0. And then we have a point in between A and B that is above the x-axis that we'll label C with x coordinate x and y coordinate y. And then we've drawn the altitude of this triangle, which has a height of y, and the distance of the right triangle formed by A, C, and let's call this D. Let's make a little point here. We'll call that D. So the triangle ADC has height y, base x. But the triangle that we're actually concerned with using the law of cosines with is the large triangle ABC. The cosine of A is then equal to x over b. And the sine of A is equal to y over b. Which we can then say x is equal to b cosine A and y is equal to b sine A. So then this point C, that is xy, is also labeled as b cosine A and b sine A. We can then use the distance formula between points C and B to find the value of A. The distance formula says that the distance of A is equal to the difference of the x values squared plus the difference of the y values squared. So I'm going to take C as the first point. That's going to be b cosine A minus C squared plus b sine A minus 0 squared. I'm going to square both sides and say A squared equals b cosine A minus C squared plus b sine A squared, because b sine A minus 0 is b sine A. I'm going to use the exponent law that says the product of two variables to a power is equal to the product of each variable to that power. So AB to the n is the same thing as A to the n, B to the n. And I'm going to expand the right-hand side and distribute that squared. So b cosine A squared is b squared cosine squared A minus 2bc cosine A plus c squared plus b squared sine squared A. And I was expanding this perfect square here to get, let's say if we had a minus b squared, that's the same thing as a squared minus 2ab plus b squared. And that's where my three terms came from. Recognize that b squared cosine squared A and b squared sine squared A share a b squared. I'm going to rewrite that, combining those two next to each other. Minus 2bc cosine A plus c squared. Factoring out the b squared, I have cosine squared A plus sine squared A minus 2bc cosine A plus c squared. And remember, cosine squared A plus sine squared A is just 1. So that's B squared plus C squared, I'm just going to move that term closer to the front of the equal sign, minus 2BC cosine A. And so now I can find what A is using the sides B, C, and the angle between the two of them. This formula can be duplicated for side B and side C as well. Here are the 3 different versions of the law of cosines and their alternate forms solving for the angle that is missing. For the first one, that's what we just proved above. Then if you use B squared, notice that we have it in terms of the sides A and C, and the angle is B. For C squared, we have sides A and B, and the angle is C. So if you solved each of these 3 for the cosine A, cosine B, cosine C, you would get the alternate form that we have written here. So you can use any of these 6 formats. How do we solve an oblique triangle then, given side angle side? Remember, solving a triangle doesn't just mean find one side length. You need to find all 3 side lengths and all 3 angle measures. Here is the way in which you should approach solving an oblique triangle, given side angle side. Okay, first you want to find the length of the side opposite the known angle using the law of cosines. Then you want to find the measure of the angle opposite the shorter of the 2 given sides using the law of sines. Or you can use the law of cosines to find either remaining angle. It's up to you. The last thing you want to do is find the missing angle using the fact that all 3 angles add up to 180 degrees. When you have a triangle that has 3 sides known and no angle measure known, then we need to use the alternate form of the law of cosines. When I'm writing the law of cosines, let's say I'm trying to find side A. A squared is equal to the other 2 sides squared, summed, and then I take away twice the product of those 2 sides, BC, times cosine of the angle of the side I'm trying to find. Solving for the cosine of A to give the alternate form, I would have A squared minus B squared minus C squared divided by negative 2 BC, but that's a bunch of negatives that I don't want. So what I'm going to say is that is the same thing as the cosine of A equals, I'm going to change every single sign and rewrite it to say that's B squared plus C squared minus A squared all over 2BC. If you just remember one law of cosine, then you can solve to find the alternate form and work through the formulas that way. The way in which we solve an oblique triangle given side, 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 there's a method just like there was for side angle side. Here are the recommended guidelines for solving an oblique triangle given side, side, side. You want to find the largest angle of the triangle, which is opposite the largest side, using the alternate form. And then you want to find either of the remaining 2 angles using either the law of sines or law of cosines. These are both going to be acute because the angle that you found in the first step is your largest angle. So if it's obtuse, then they're both going to be acute. If it's acute, they're also both going to be acute, just smaller. The law of sines is easier to remember, obviously, but you're dealing with rounded values, whereas the law of cosines involves the lengths of the 3 sides that you're actually given might be more accurate. The last thing that you want to do is find the measure of the missing angle, subtracting the 2 angles that you have found from 180 degrees. We saw with the law of sines that there was a way to calculate area using the sine of an angle and the 2 sides rather than 1/2 base times height. We can now calculate using Heron's formula for the area of a triangle. If you have 3 sides now, we can find the area using just those sides rather than the height, which might have to be an altitude where you might have to find an angle measure for that. So S is the semi-perimeter, meaning you find the perimeter and cut it in half. And then to find the area, you take the square root of s times s minus one side times s minus another side times s minus the third side. And this will give you the area. So those are two different versions of finding the area of a triangle now. For the first standard formula for a triangle, you need to know the altitude or have a right triangle. For the second one, you need to know two sides at an angle. And for the third one, all you need is three known side lengths. Head on over to the skill practice to see the law of cosines, solving triangles, and solving the area of a triangle using Heron's formula.